Problem reads as follows. A homeowner wished to enclose a rectangular patio with an area of 4,000 square feet. The patio is to be enclosed on 3 sides by a brick wall costing $20 per foot, and on the remaining side by a fence costing $15 per foot. Write a function to model the cost of the enclosure as a function of the length of the fence. What length of the fencing is needed to minimize the cost of the enclosure? What length for the fence will make the cost of the enclosure $5,000? The independent variable in this problem is the length of the fence, and the dependent variable is the cost of the fencing.
Part A of the problem asks to write a function to model the cost of the enclosure as a function of the length of the fence. So we started by drawing what the patio would look like, and we made sure that one of the sides, labeled 15y, is the side that is against the brick wall. So we started by looking at the numbers that we were given, and we know that area equals length times width, or in this case, x times y, and we know that the total area of this enclosure is 4,000 feet squared. So if 4,000 equals xy, then in order to find y, you would divide both sides by x, so y would equal 4,000 over x. And we know that the perimeter equation is 2x plus 2y, and we can use that to plug it into the cost equation, and we know that the cost of 3 of the sides is 20, and one of the sides is 15. So if you plug that in, you get cost equals 4x plus 35y. So if you take the cost equation we got in the previous step, and you plug in 4,000 over L for x, then you should be able to get the cost as a function of the length is 160,000 over the length plus 35 times the length. We put this function into Desmos, and you can see that this is what the graph looks like that matches the equation for the cost in terms of length.
Part B of the question asks what length of fencing is needed to minimize the cost of the enclosure. First, we're going to want to change our window so we can see the minimum point of the equation. I changed my window to have a y minimum of -5 and a y maximum of 6,500. When you're satisfied with the graph and can see the minimum point, you'll want to press second calc and then click on the third function that will allow you to find the minimum. Once you've selected the third option, it will take you back to the graph and ask you to go left bound. This means that you will go to the left of what you think the minimum point will be. Once you have gone left, press enter as an estimate. It will then ask you to go right bound, so you will go to the right of what you think the minimum point will be, and you will again press enter. Once you've gone left bound and right bound, it'll ask you to guess, and you can just press the enter button a third time. After the guess step, it will then calculate the minimum point. In this graph, the minimum point is 67.612, 4,732.863. Therefore, the length of fencing needed to minimize the cost is 67.612 feet.
Part C of problem 2 asks what lengths of fencing will be needed to make the enclosure cost $5,000. So in order to do this, we had to graph. So the first equation that was used was the original function, which was C of L equals 160,000 over L plus 35L. And we also had to make an additional equation to account for the wanted enclosure cost of $5,000, and that equation was just y equals 5,000. The group then typed the two equations into the sides of Desmos, and Desmos produced the graphs of both equations, and we then use these graphs to look specifically at the points where y equals 5,000 intersected the original function's graph. As we zoomed in on the graph, we were able to see that the line y equals 5,000 intersected the original function at two different places. The first place was x equals 48.394 and y equaled 5,000, and the second place was x equals 94.464 and y equals 5,000. We were able to use these 2 points to determine the minimum lengths required to make the enclosure cost $5,000. After interpreting the data that our group collected from the points of intersection on the graph, we came to the conclusion that the minimum lengths needed for the enclosure to cost $5,000 were 48.394 feet and 94.464 feet.